Yeah, good afternoon, everyone, and good evening, good morning. We have people from India, Europe, and in many parts of the United States. And depending on their times, it may be morning or evening or afternoon, and so on. So welcome everyone to join us for the webinar, ARA webinars. You will hear some updates from about ARA project progress, and also we're going to discuss a few things related to beta testing, and also followed by a live demo from our audio teams. Before we start, I'd like to propose to take a moment to remember and pay respect to our great colleagues. Dr. Ahmad Kamal is a great colleague and researcher and ARA leader. And Dr. Kamal was a co-PI for the ARA project, and he passed away this past Sunday. And so he also co-chaired the infrastructure working group and the research working group. So I and Dr. Kamal and I are co-chairing the research working group. So that's why we are organizing for these webinars together until last Saturday, and things went by and so. So Dr. Kamal has been working for Iowa State for 20 some years, and he was a Richardson professor for the Department of Electrical and Computer Engineering at Iowa State. And also he is recognized as an IEEE fellow for contributions of wireless and mobile networks, and done a lot of research in cognitive radio networks and optical networks. We'd like to take a moment to thank him for his leadership, for his contribution to ARA project, and also seeing the nice words and also nice things they experienced together with Dr. Kamal from colleagues, from his former students and friends. And so the details will be posted on the slides if you get a chance or interest to read it afterwards. For this webinar, we're going to have 4 major components. And so the first thing we do, we will provide you an update about ARA project, and it will be done by Hong Wei, which is the project PI for ARA. And also we're going to have a discussions about community engagement activities. My colleagues Mara Cohen and Marie and Hong Wei, and I will discuss a few activities, and we hope to get you interested and join us for those activities. We're going to talk about the details later on. And then we have a live demo from our audio lead, Saras Babu, and Saras got his PhD from a university in India. And right now he's leading the ARA audio teams. And also we have a key members, Tamer Islam. And so also focusing on the infrastructure working group activities. And also we have the co-PI, Dr. Mai Zhang. Mai is a co-PI and leading the AirSoft, which is a software working group activities. And then at the end, we'll have about like 18 minutes or so for the Q&As. So if you have any questions, any suggestions to us, feel free to let us know and use that time for Q&As. Okay, that's kind of the agenda for today's webinars. So without further ado, I'd like to ask my colleague, Project PI Hong Wei, to give you the updates. So let me stop sharing the screen, and then Hong Wei can go from there.
Okay, great. Thanks a lot, Yong. Thanks everyone for joining us. Just as a note, as we go through the update and presentation, feel free to use a chat box to share any comments or questions. We can don't feel that you have to wait until the end. Also, you can also chime in as we go through some of the discussions and materials here. Let me share my screen here. Okay, right. Can you see this slide? So can folks see this slide, Yong?
Yes, that works.
Okay, great. All right. Thanks again for taking time to join us here. I have seen quite many familiar names. I think we have worked with several of you. Many of you actually in the early project planning phase, and also back in summer 2021, that's when we had our first workshop. So in many ways, this is a regathering of folks, and also very glad to see many new friends here. To what I would do in the coming probably 15 to 20 minutes is to give you an update about where we are, what we have been doing in the past 2 years, and what kind of research that can be enabled very soon. So let's jump in. So as we all know, well, if you have paid attention to ARA, we know that ARA is one of the four power platforms in US. We focus on enabling research, education, innovation for rural wireless systems. To that end, the deployment of the Living Lab is such that it consists of two major components. One is this long distance high capacity X-Hall solution, or which we call the ARA Hall, that spans over these different sites by plan. And then at each of the sites, we also have access networks deployed. And then in the city of Ames, where ISU, our university, resides, we have a little bit denser deployment across farms, research park, and some of the city halls. So the deployment is such that it actually features state-of-the-art agriculture farms and facilities. For example, we have, as we explain a little bit in more detail shortly, we have state-of-the-art crop livestock farms, as well as farm facilities like green mill, biorefinery, and also the kind of user equipment you can use, like 5G and beyond user equipment that can be used in advanced ag vehicles, robots, drones, cameras, and sensors, and so on. So most of this is actually in the near term is for sensing. For example, cameras in the field or on the vehicles, on robots, but there are some feedback control that can also be done. For example, there's environmental sensing control systems in the livestock farms. There's also a solar farm that's going to be in the coverage range. So besides agriculture, we also expect to have coverage of some of the representative rural communities, including airports, traffic infrastructures, public safety facilities, vehicles, and so on. So that's a very high level about kind of deployment plan. In terms of technologies, platforms, here's a quick summary. For the long distance high capacity wireless X-Hall or backhaul solution, we are using platforms that's operating at a diverse spectrum band from the free space optical to millimeter wave to microwave, right? They provide different capacities, but all at relatively long distance. So for the free space optical link that we're developing right now, that can potentially provide more than up to 160 gig BPS capacity. So the deployment and also the orchestration of the infrastructure is such that users, for example, you folks can actually come and use, try to find the different ways of using all these diverse platforms for different research problems, which we'll briefly touch on shortly. So that's on the X-Hall or backhaul side. And then on the access network, this is where we would see those kind of 5G and beyond platforms. There's the low UHF massive MIMO system that we're working with Skylark Wireless. There's state-of-the-art 5G massive MIMO and the millimeter wave platform from Ericsson. And also there's the advanced SDR systems from NI. For example, there's N320 as a base station and then B210 as a UEs. So all these platforms would be able to enable essentially a wide range of experiments, as we would discuss shortly. Just a brief note about the, given that I think spectrum innovation is going to be one of the use cases, use case directions. Here's a summary about the spectrum coverage of the SDR platforms. Most of the SDR is going to work at sub 6 or 7 gigahertz band. We have some millimeter wave radio unit but tentatively, I think the deployment will be in the sandbox instead of outdoor. In the outdoor, we may have one or two links, but the majority of the deployment will be in the sandbox for the mid-wave band. And then for the cards or custom built platforms, we have the RF sensors that operate at sub 6 gigahertz band, and also there's ARA and Hall radios that's operating at bands from the microwave to all the way to the free space optical. The free space optical link that's being built is operating at the 194 terahertz band. Besides some of the state-of-the-art XHAW and access network platforms that's being deployed, integrated, and will be available to you, we also envision the use cases and will be able to support the use cases where you may feel that, well, I may want to have some new platforms that can be deployed here for experiments, so that we would also be able to provide that kind of support. Essentially, a lot of the groundwork has been done. If you have a new antenna design or front end design, we can actually would be happy to work with you to integrate and then experiment that in the real world settings here. So, for example, right now we're actually working with Microsoft Research in deploying their we support TOY space IoT platforms as an example of BYOD support. So that's the overall plan. In terms of where we are, we have been working very diligently in the past, I guess, close to 2 years now. We are close to the finish line of the phase 1 deployment. So as of today, we have 4 base stations deployed around the city of Ames. So it's being circled here, right? There's a Wilson Hall, Curtis Farm, Research Park, Agronomy Farm. So there are 4 base stations deployed in an area of a diameter of about 7 miles. So for example, between Agronomy Farm and Research Park, it's about 7 miles distance. And then for the ARA Hall, we also have deployed a multimodal link between the Agronomy Farm and the Wilson Hall site, between the Agronomy Farm Wilson Hall site. So that's on the base station and the access network base station and ARA Hall deployment. Essentially, there's a very good spatial geographic coverage of the deployment. And then on the UE sides, we are essentially in the process of deploying up to 20 UE sites around these base stations. In this map, the stars shows the base station, right? This is the Agronomy Farm base station, Curtis Farm base station, Wilson Hall base station, and the Research Park base station. And then there will be UEs deployed around these base stations. Most of the UEs will be fixed so that it's always available. Some UEs will be mobile, like 3 to 5 UEs on the buses, fire commander vehicles, or robots, or agri vehicles. There will be a few that's actually mobile that can move around the farms or the city road. So as of today, we have 7 sites, UE sites that's marked in green here. That's already deployed, integrated, and ready for use. Additional up to 13 sites will be deployed in the coming 1 to 2 months. Those are marked in blue and also the brown colors. By the way, we will share the slides. Also, some of the information is actually on the ARA user manual, as we'll briefly touch shortly. So with this deployment, it's going to be able to support a wide range of experiments and research. Here are some examples. For example, there's this state-of-the-art, probably first of its kind, long-distance, high-capacity wireless XHAW deployment. So therefore, for folks interested in this, you can look at different aspects of this research direction. There's also the first of its kind, the TOY space massive MIMO deployment. And another unique feature for the massive MIMO deployment is that we are working with the Skylar in bringing their production quality implementation to the research community with programmable APIs so that you can actually gain deep insight into the behavior of the relevant channels, system behaviors, and so on. And then there's also the fully programmable SDR-based 5Gen Open RAN systems that can be experimented in ARA. We have tested out on the base station sites. We are in the process of integrating the UE sites that hopefully will become available very soon. And then, of course, there's a state-of-the-art Ericsson 5G massive MIMO and memory wave systems that's available. We do expect this to be able to at least be able to provide richer information than what's available in the commercial deployment today. Even though it's not, unlike Skylark or SDR, this is not always open, but we still expect there will be a little bit more information available to the research community. And then with all these platforms, you can actually look at spectrum innovation dimension, right? We have some examples which I will touch on. And then, of course, we are not just looking at the access network XHO, but there's actually end-to-end cyber infrastructures involving wireless, fiber, edge, and cloud computing resources. So they can run experiments that more fall into these directions. So that's on the wireless research, some example directions ARA is going to be able to enable. What's unique for ARA is actually we do not just focus on wireless, right? But we really want to put wireless research in the specific context of high impact application settings. So here are some examples of the application research that can be enabled for folks who are more interested in this. For example, colleagues in agriculture, there's a high throughput phenotyping, agriculture automation with drones and ground vehicles in the farms. Also, precision livestock farming, for example, having camera arrays monitoring the health behavior, right, of the, for example, in the case of the, I think these are the, these are the, I think the, I forget, is this cow? No, not cow. These are probably a beef nutrition farm. This is a beef nutrition farm there. And then there's also potentially the use of with the high capacity, low latency communications. We can look at AR, VR based education exercises that can be brought to the classroom. Just maybe that's kind of a broad summary about the kind of wireless application research we are envisioning and have started experimentation already too. Just to give you a little bit deeper insight into maybe just one dimension of this on the spectrum related research, we have started just hope in the hope of providing some kind of data to the broad research community. We have started looking at, for example, how we can use the ARA deployment, for example, the TWY-based massive MIMO deployment, together with the IoT deployment to look at spectrum sharing between in the TWY spaceband across broadband solution systems, IoT solutions, and also the incumbents. So part of that would be to understand the spatial temporal spectral diversity and dynamics. So here's a figure kind of showing the temporal dynamics in the ARA footprint right now. So the x-axis shows time, kind of in time unit slot, and then y-axis shows out of the 40 TWY space channels, how many channels are actually available for wireless communication use. So as you can see, there's actually good temporal variation here. And then we also look at the spatial diversity. In particular, we looked at across the 40 channels, TWY space channels, and look at the two base station sites, the agronomy farm and the Wilson Hall. This map shows over time what are the channels that are available at both sites, right? If you see a time slot and a kind of time and frequency slot showing as a white, that means this channel is available at both sides. Again, you can see there's actually complex patterns that's here. These have actually deep implications about how the related communication capacity feasible, and also how we can potentially develop solutions, spectrum sharing solutions to enable different kind of use cases. Here's another slide just to give you a high-level intuition of the fact that in the rural settings, in the farm settings, there are actually many unique patterns that may not be there in other use cases. For example, we have seen that the crop type, just the type of crop, the density of the crops would have huge impact about the channel behavior. For example, they could need to up to more than, depending on situations, the variation of signal strengths could be more than 16 dBm. So that's a quick update about ARA as a testbed and also the broad areas of research enabled. Now, as Yong have alluded to, the main reason we are building this testbed is to make sure that make it hopefully to make it as a useful tool for all of us in the community, especially for folks who are for the that's not part of the project team actually. So really, we are looking for ways to help, right? To help assist what the community is interested in. For example, one of the near-term focus, right, or immediate-term focus right now is essentially make sure that we can deliver ARA as a robust platform that you can actually count on, so that it's not something is available in one day but not available in another day, right? So we can make sure this is a platform you can use to count on when you plan your research and education effort. Another effort where opportunity, I think, which is quite exciting potentially, is that by making ARA as a useful platform and working with folks who are passionate for use-driven, use-inspired research, and also care about potential real-world impact in the near term, we can potentially form communities actually. For example, if there may be a group of us maybe interested in some topic, and then we can potentially work together to tackle some of the grand challenges, right, from the basic fundamental research to applied research and prototyping and so on. So I'll come back to this shortly. I guess another area that we hope we can be of some assistance would be to help amplify the impact of your work. For example, we will have newsletters that can be used to feature some of the representative research and education activities you lead using ARA. We also be able to will be more than happy to feature your research and education effort in some of the high visibility events. For example, as early as this first week of September, we expect to have this ARA public launch event. That's where we're going to have one of the effort there would be to feature some of the high impact research activities, right? We would have demos available at that time. So it will be a very exciting event with, I think, the broad stakeholder participation from federal agencies to industry and academics and government. And also aligned with the second bullet point here, we do hope to be able to work together to hopefully facilitate ecosystem partnership that can also allow us to think about how can we even go beyond traditional academic research, right? Be able to even transition some our research results into practice and impact in the foreseeable future. So now, if I may come back to this ecosystem and the community building side, essentially we do hope that together we can actually nurture like-minded folks who are interested in wireless, in the use of wireless in different kind of application domains, be it sensing or control or extended reality or streaming, and also the use of those technologies in different application domains such as agriculture, education, and so on. Right. So, so far we already have about overall more than 65 partners that come from national labs, universities, industries from different sectors of industry like wireless systems, vendors, carriers, application communities, and also organizations that actually would be able to deploy and operate infrastructures, advanced wireless infrastructures, and also the end user communities. And so just to give you one example, I think one of the specific activity we would love to work with you or for folks who are interested would be this, the action clusters, where we would look into the opportunity of how we can build cross-sector teams that can with each one of them could be focus on one or two grand challenges. For example, how to actually enable ultra-reliable low latency communication in field and be used in the real-world applications, or low power, ultra low power IoT applications, or data science for wireless systems. Right, those could be some candidate topics, or maybe there may be interest about open source initiatives, or open innovation with strong industry participation, and also next-gen education in general, and next education using ARA. Or in the application sectors, agricultural automation, edtech, or research translation activities in general. So this is where we would very much love to hear your thoughts. If anyone would be interested in certain topics, we can look at mechanisms by which we can work together to, I think every topic is broad enough. I think there are actually some very open questions that need to be tackled before we see, pervasive deployment of some of these advanced technologies. We'd love to see if any of you would be interested, we'd love to work with you to look at how we can get this to work. Okay, so that's just some example, I guess, high-level idea about how we are thinking about we can be here to assist, and also one example of specific activities we would very much love to work with you. And then another, we have actually also been making progress in other dimensions. For example, there's a new open source ecosystem project that's just started. So I guess we'll have my colleague Myra to share a few words about the Opera project. Myra?
Thank you, Hongwei. Did you want me to share my screen? Or?
Yes, please. Yeah, I'll stop.
Thank you. So I'm Myra Cohen, and I'm a professor in computer science, and I've just joined the ARA team, so I'm not part of the core ARA project, but I'm part of an early planning phase. We're trying to look how we can build an open source ecosystem for ARA based on top of it. So our project called APRA is just in the early phases, and the idea is that we want to be able to use the ARA research experiments, the software, the data, the hardware design to help build out a community ecosystem of open source artifacts. So not just even the software, but also our data and our hardware. And so the goal is to be able to build a set of rural applications, such as you've seen recently. You've just seen all the precision agriculture, but also ed tech and even advanced manufacturing, and bring that, use the ARA infrastructure to build those applications. We plan to do all this in an open source environment, so using ONF and open air interface, et cetera. And the great part for you is that we're just starting. And so the advantage of that, and talking about it today, is that we think there are going to be a lot of opportunities in Opera for the ARA early adopters. So my background is in software engineering. My research is in software testing. And so we want to think about how we can build a really robust ecosystem, use best practices, and bring everybody on board. So if you become an ARA early adopter, you'll be able to help contribute and build the ARA Opera ecosystem from the ground up. And so I think that's pretty exciting. You'll be able to give us input on data collection and our data set structure, future features and changes, and you'll have a chance to help us shape the future of the broadband prairie and this whole open source ecosystem. So I just wanted to say a few words. We are looking now for beta testers, and Young will talk to you more about that. But I want to just tell you a little bit about why we think you should join us and become part of our beta testing team. So this is going to really give you a chance to work with ARA in its initial rollout. You'll be able to develop early use cases. You'll be able to find issues and problems and help us figure out better ways to address them. And as part of ARPA, we're developing training material. So we're going to be looking at best practices for testers, and we're going to build that material and start sharing that as we start doing our beta testing. So we're going to give you the opportunity to learn things about what are the best ways to partition data and things about equivalence classes. how are you going to cover our use cases and the huge parameter and configuration space that we're already seeing just in the small ARA environment that we have. Things like testing boundary and error cases, so all aspects that you might not have thought about that'll sort of expand your opportunities to learn about best practices in testing these systems. And last, we're actually starting to build, we're hoping during this beta test, we're going to ask you for feedback. We're going to ask you for some information about what you tested, what configurations you tested and results. And we're going to use that to build a coverage map. And the idea is that you'll be able to help us. We'll give you access to that coverage map, and you'll get to help us fill in the white space as you test. So it'll be kind of a fun activity. You'll start to see how much of that space we've covered, and you'll see where you can help us and where you can do other testing. So with that, I think I'll pass it back to Young, who's going to talk more about the actual beta testing.
Thank you, Mara. And yeah, so, I forgot to introduce myself to the I'm Yung Guan, a professor in computer engineering program at Iowa State University. I'm the co-PI for the ARA project and also working with Mara, Hongwei, Marie, and a few other colleagues on the ARA project. So just like Marie mentioned, so we are recruiting and people who can join us earlier at the early stage of ARA project to help us to maybe become a user, the early user of ARA, and also help us to do the beta testing. So at this stage, so we've done the alpha testing ourselves with the ARA audio team members and students, and also we've done some internal beta testing work done in the past, and so we use the students and at Iowa State University to do the initial beta testings. And at this stage, we are asking for help from the large wireless communication and networking communities, like the attendees like you joining us today. You can help us to do some beta testing work, and just Mara side, so we really need the help. And so in terms of the testing plan, so the goal is trying to test the functionality and also efficacy of the ARA infrastructure using a developed ARA web portal system. And so right now, so like many other testbed environments, so we do have a ARA web portal systems. You can log into the web portal systems, and also you can reserve resources at different sites and different type of devices. And also you can use the container and virtual machine technologies to allow you to utilize the compute node and also all different type of wireless devices, resources, equipments on ARA testbed environment. So right now, so the basic functionality of ARA portal is working, and so maybe it can help us to do the initial beta testing work to evaluate whether the user authentication solution is satisfactory, is sufficient, whether any suggestions to us like to do a better job in terms of offering or providing the ARA resources, and also different ways for container instantiation, and also the performing and conducting the actual experiment on using the ARA testbed environment. So we plan for a 3 weeks long beta testing. So we roughly like to start the beta testing work on May 25th and spend about 3 weeks on that. So during the whole process, and we'd like to hear some early feedback, and especially some issues and bugs if you are helped to identify from a web portal system, and also all different type of deployed ARA resources. So you're welcome to join us, and we appreciate all the efforts you made and help us to make the ARA project better and ARA platform more usable and robust and stable to the users. And there's a email address contact address on this list, and also we're going to make announcement on the email address on the ARA web pages. In terms of the testing approaches, and so we provide a simple ARA web page containing the information about the resources and also the user manual, which is available on this link. And so you can download, you can go into this link and go along this link and look at the material we provide to you. And also we provide a number of sample testing cases and listed here on this link. And so this is a publicly accessible link to our Sidebox folder. You can take a look at the sample testing cases, and there's a simple description about testing cases. And also, if you help to do some experiments on ARA, maybe it can help us to collect those output. For example, the functionality on ARA platform is in the working conditions, or there's any issues or any difficulty to get access to those functionalities, and just feel free to let us know, and so on. So we prepare a Excel sheet for you to use. So if you help us to do some experiment and just copy paste your results into the Excel sheet, and also the Excel sheet allow you to specify, give the specific information about what type of experiment you run on ARA and what type of results you get, whether it's consistent with results expectation or not. And so if you find any issues, any bugs, or any difficulty to utilize these services, the resources, and feel free to copy paste and write into the Excel sheet as a remark. And so there's a 3 tabs in there. You can certainly create more tabs. So when you send us feedback and suggestions, maybe just send this Excel file, maybe some like a screen captures and an error message and so on and so forth, and send it to us. So this email address will be posted on the project website. You can take a look at it, and then you can use it to contact us. And so feel free to send us any information that you think useful and helpful to us to improve our ARA platform. Okay. Hongwei, back to you.
Okay. Yeah. Yeah. So we have prepared. I noticed some of you have helped also already share your input on the participation survey. So I think that one of the near-term action item for us would be to work with folks who may be interested in participating beta test, or if not beta test, some of the early use cases. So we have a survey that's provided here, which can also be found in the ARA blog. We have a blog page, ara.org, arawatch.org/blog. The latest one, there's actually a link there, also other information that's there. Please do feel free to check out. So if you may be able to help, if you're interested in beta testing or some of the early experiments, if you can help share your input by Friday next week, that'd be fantastic. It's a short survey, probably take about no more than 5 to 10 minutes of your time. Feel free to share with other friends, with your colleagues, with your teammates, and so. Also, ARA is not really, ARA is a community platform, right? We are, folks who are speaking today, we are kind of the builder, but really it's a shared platform. We very much look forward to hear from you on how it may have served some of the use cases, but how it can also be improved, right? Even in also any feedback or thoughts about how we can work together in using ARA. Those are all very invaluable feedback. Feel free to reach out to us at e2@arawatch.org if you may have any suggestions. Just one final note. We intend to use we have a Google group called ARA-users Google group. We intend to use that as a main communication platform with our user community, our friends here. If you have not actually joined there, if you could take a moment to join ARA users Google group, that'd be great. Thank you.
Thank you, Hongwei. Next, so we like to keep the questions to the end, and we have a separate Q&A sections, so you can ask questions and give us some feedback about this webinars and so on. So I'd like to take the time for our colleagues, our ARA audio lead, Sarah Bruce, to give you a live demo on how to reserve resources and run a very simple experiment using the deployed ARA platform infrastructure, the resources on the our infrastructure platform. Thank you. Let me stop sharing, and then Sarah, so you can go from here.
Thanks, Professor Young. Can you hear me?
Yeah, we do.
Okay, so let me share my screen quickly. So can you see my screen?
Yes.
Okay, so hi everyone, I'm Sharath. I'm working as a research scientist in ARA, and I'm leading the software working group along with Professor Yong and Professor Mai. So just to
So,
give a
Saras,
uh-huh.
Saras, before you move on, would you be able to turn on your camera?
Oh yeah, sure. Sorry
Thank you.
about that. Uh, uh, by the way, where is the option? Yeah, here it is. So let me reshare my screen. Yep. So I just want to give you a flavor quickly of how we can approach ERA and how you can execute your experiments. So today, just we prepared a small demo that's kind of measuring the link performance of one of the MIMO platforms that we have. It's actually from Skylark. So I just to give you the experiment setting, how you will do that link measurement. So the idea is something like this. We have a MIMO base station that is deployed at one of our sites, Wilson Hall, and we have two user equipments, or CPE you can say, customer premises equipment, that are deployed at Curtis Farm and Ames location. So you can see from the Google map, it will look like this. We have the base station here, and we have one UE here and one UE here, and the the base station is having an established link with these two UEs. And assume that you want to just study the link measurement characteristics of the link. So that we can do it from the data center. You can reserve a node in the data center, and you can measure some of the characteristics of the link. This link, that is Wilson Hall to Ames and Wilson Hall to Curtis Farm link. So I'll show you how we can do that in ARA. So this is the architecture, ultimately the experiment architecture, if you see. So we have actually, we need to go to our portal. So the portal address is actually portal.arawireless.org. So if you go here, you can have a login and password. So we are working on the federated login to make it easy for users to log in using their institutional credentials. So just for the sake of, we are working on that, and we will make it available soon. So now we will just, for the sake of this demo, I will go with our friend, that is John Doe. I think everybody know who is John Doe. Let's see our friend in internet community. So let me log in to the portal. So if you log in to the portal, you will go into the basic summary page, where you can see the resources that are used and all those stuff. And one important thing I want to mention is that I think most of you might know about this interface. We actually developed the entire software platform based on OpenStack. So this is following the OpenStack style of the user interface. So for the experiment that we discussed, so we need just a compute node reservation here. And from that, you can actually measure the link characteristics from here. So we are going to reserve this particular node for this user. So how we can do that is something like this. If you go to the project, and you have a reservation tab here, then you can go to the leases here. Then you can see, if you look at the host calendar, you can see what are the nodes that are available to work on or do the reservation. So we need just a data center compute node. So if you go to here, then if you can create a lease, that's actually you are creating a reservation. So I can just give a name, and just I'll leave most of the fields blank for this demo. So just give a name. Then the thing is that this is one of the major difference that we introduced from OpenStack. Here you can actually specify the resources using three attributes. That is the site. These are our deployment sites. You can see. So for us, for our experiment, we need a data center compute node. Then in the resource type, we can select the compute. If you are using some of the other RAN experiments, you can select the particular site, and you can go to run experiment or backhaul experiment, that is ARA hole experiment. So for now, we are going to use just a compute node. Then I can go here. These are some of the wireless resources that is specifically required for some of the 5G experiments. I will keep it blank for now. Then if I create lease, what exactly happen is a lease will be created. It means that particular computer will be reserved for you for doing the experiment. So now it is pending. So if you just do it, you can see that it became active. It means that this data center compute resource is actually available to you for doing your experiments. So that is reserved. Nobody else can use that. So you will get an ID, reservation ID for that. Then what we need to do is we need to go to that particular host and we need to launch a container. So one of the speciality of ARA is that we are doing a container based resource reservation, that is not virtual machine based, it's a container based thing. So you need to launch a container on the reserved resource, and then you need to execute your experiments on in the container. So now I will do the launching of a container on the particular reserved resource. So for that I need to go to this container. Then you can see that there is no container now. I can create a container here. So for the container, what I'll need to give a name. Then this is very important that you need to give the image. Maybe your experiment image will be available in Docker Hub. As part of ARA community, we are also giving some of the pre-built container images so that you can do the experiments. So this is one of the container images that is available. You can see that in our user manual, we actually specified this experiment, the measurement experiment. So we used to give the containers that are available. So this is exactly the container image that I provided. Then you can give some of the, so it can be downloaded from Docker Hub. Then you can give what command you want to run when the container starts. Then go to the next. Then you can give a host name for your container. I'll just give MIMO. Then here you need to select which lease ID. This lease ID is actually representing the lease that you created. If you can create multiple leases, if you are doing some other experiments, you may need multiple nodes. So you can create multiple leases. So you need to create which lease you want to launch the container on. So since I have only one lease, I just selected that lease. Then I need to move on. Then just attach a network to the container so that it can access internet and it can communicate with some other containers that we have. So you can see that the container is getting created. So it's in the creating stage. So if you refresh, you can see it's running. So if you click on the container, you can see the information of the container. So what we did till now is we reserved a particular computer here, and we actually launched a container on the top of that. So in this container, we have some pre-built API wrappers and commands that are provided to do this measurement. So in order to do that, what you need to do is you can go to the console to access the container, then just click here. So you are in the container. So now you can start doing your experiments. So in this container, you can see that we are providing a script that is specifically built for the link measurement, the MIMO link measurement. So I will just run the script. That is this ARA SKLK client. This is a client program that created for measurement. And if you do a help, you can see that the commands that we provided. So this is kind of a initial set of commands that we provided for measurement. From your feedback, you can also run these experiments, and if you have some feedback or you want some commands, additional commands, just let us know that we will try to integrate that commands into this container so that you can just download the image and just launch the container like this. So I'll just run a simple command to get the status of the link, the MIMO links that we have. So for that, there is a command called get UE stats. So you can see that, as I told, we currently have the setup that this base station is connected to these two links. And actually, this is representing the first link from the Wilson Hall to the Ames UE. This is the first link, and you can see some information about the SNR, then the data rate that you can see in the downlink and uplink. And here is also there is downlink and uplink. This is towards the second CPE. This is one CPE actually. This is the ID for the first CPE with downlink and uplink. Then the second CPE downlink and uplink, and such things. And there are some other commands like get physical configuration. So you can see some other informations. So like this, you will get access to the particular nodes for doing the experiments, and you can run whatever commands that you want. And this container is given access to internet so that you can ping to some of the nodes. For example, maybe I can try to ping one of the no, ping command is not there. So if you want to install the ping command, you can do IP utils ping. So you can install the command. Then if you want to ping internet, you can ping internet. Then some of the IPs, if you want to ping, let me see whether some of the IPs are available. 40, 41. No, some of them are not available, but I'm just mentioning that these containers are provided with internet, and you can install packages of your choice, the Python libraries, or depending on your experiment, that whatever you want to do, you can do. So after running your experiment, you can just what you can do is you can just stop the container, or you can delete the container and just make the yeah, it's stopped now. Then maybe you can go and you can just delete the list, so that that computer will be available for some other experimenters for use. So that's what just I want to show, just running a simple hello world kind of measurement experiment. And we have a user manual with some of the experiments that's specified. And you can also submit your experiments and specifications as Professor Young told. We have an Excel sheet with some experiment specification. You can fill in what are the requirements, hardware, software requirements, and everything, so that we can get the feedback what kind of use cases that you have, so that we can prepare ARA for you to execute your experiments, and make ARA useful for all the other community members as well. So that's what I have. Professor Young, back to you.
Yeah, thank you, Saras. Yeah, for the great demo. And so share the screen. So in this demo, want to point a couple of things. This is the base station on the Wilson Hall, on the top of the Wilson Hall. You probably see the photos Hongwei shared is on the top of the ceiling, the tallest building in town. And then the Ames UE devices actually installed on the water tower about 0.6 mile from the Wilson Hall. And then we have the Curtis Farm installation. So that's about 1 mile or 1.2 mile from Wilson Hall. It's two different devices. And so when Saras run the ping command, and that's actually use the compute node on the data center on campus, on IVC campus, you can see the connectivities with those UE devices and so on. So next thing, the last thing for the webinars, we have about like 5 to 6 minutes. We have little time left for the Q&A section, but certainly so we keep the email addresses Hongwei and I share with you on the slides. We're going to share the slides on the project web page, and also feel free to email us if you have any questions or suggestions. But we do have time for some questions. And
yeah, sorry, it looks like it took us a little bit more time than we thought to share some of the updates. I think several of us will be available. I know probably some of you have other commitment at right after 1:30 Central Time, but we will be available for a few more minutes. If anyone want to stay, we will be happy to. Yeah. All right. I guess any comments, questions, thoughts? Okay, are there available examples of 5G experimentation, especially millimeter wave 5G? I think for the sub 6 gigahertz, we do envision providing example like open source based experimentation. And also for the lower band, like low UHF, the TWY space band, there will be example experiments. For the millimeter wave, we have the commercial Ericsson platform deployed. I think there may be some measurement study that can be potentially be done, but right now, as we stand, I think that may, depending on how open Ericsson is, we're kind of still in that discussion process. Depending on how that conversation goes, we may be able to support some also millimeter wave 5G measurement studies. And then if it's about application use case, then that can be done probably in a few weeks. That can be available. Maybe just a clarification. I think we feel that there's actually some good use cases for middleware in the rural settings, especially maybe in those rural towns or some of the relatively smaller farms. But in general, we do feel that some of the lower band platforms may be potentially more relevant to the rural setting, given as of today, right, the relatively sparse user base in the rural.
Can I have a question?
Yes, please.
This is Chang Liu, assistant professor from University of Nebraska-Lincoln. So I just try to. We currently have some lab scale end-to-end network slicing testbed based on OpenAI 5G,
Yeah.
as well as Open 5GS. So we try to see if we want to scale into the ARA platforms, is that possible? We can get some like a physical computer access, or we has always to be a container based?
I think the default mode of access will be container. That said, I think we are actually in the process, kind of the final phase of debugging that on the UE code. You can essentially you should be able to run OpenAI interface in the container. Also the Open 5GS, the core network. That should be, yeah. So do you have any special needs about bare metal access? We do have plan for bare metal access in phase 2. It's just we haven't get there yet.
I think it's okay. Yeah, as long as we have. So do you provide some images for the, for example,
Yes,
OpenAI
yes.
interface?
Yes.
Okay. I think then we can develop.
Yeah, then you can take those image and probably make update too. Yeah.
Okay, that should be good. Yeah.
Yeah.
Yeah. Okay.
Yeah.
Oh,
Thanks.
okay. So for the mobile users, is that are you able to what's the plans, or a little bit more details?
Yeah, so in terms of mobile UE, we have the plan for 2 buses. The 2 buses will be circling around the city. And then there's a fire commander vehicle, and also be mostly moving around the city. And then there's going to be 1 robot, 1 small agriculture robot, and then 1 large ag vehicles. So tentatively, there are 5 UEs planned. Mobile UEs planned in phase 1. Yeah. So basically, just maybe sorry, I didn't provide update on this. Phase 1 meaning by this summer, and then phase 2 will be by summer next year. By summer next year, we hope to expand this to the surrounding cities and communities.
Yeah. Okay. Thank you. Thank you so much. Yeah,
thanks,
we
John.
may have a little bit more details offline discussion. Thanks.
Yes. Oh, by the way, please feel free to reach out to us by email. We can also schedule separate meetings. I know this is a very short meeting trying to cover a lot of materials. Yeah.
Yeah, sure.
Especially for folks who may have some really cool high impact research activity that you can actually run over ARA. We would love to work with you in the coming months to hopefully to highlight some of your effort in the public launch event.
Hello, this is BP. Sharat, very nice to see you, and also Mary, yours. I'm dialing from Netherlands. So it so happened that I thought, okay, let me try to understand what is happening around here. I don't know how I can collaborate with you guys, because I'm coming from different continent altogether. So if there is any way that I can be part of some of your journey, maybe if you can drop an email to me, I'll be very happy to join. But it is really amazing that so many groups coming together and then working on an important thing. Because I'm also thinking about the rural India, because I also spent about 4 months to 5 months in India. Probably knowing your experiences, we need not go through the same path, but we can actually jump ahead and then do things, right? So that is the learning experience for me. But in any way, if I can join hands and for me to learn and enrich myself, I'll be happy. Thank you for inviting us. Thank you.
Yeah, sure.
Yeah, thanks, VP. Absolutely. We will. I think we have a few other colleagues from Europe too. Very much. In terms of use ARA, it's as long as you have internet, you can use it. But of course, I think on other activities, I think like action clusters or other effort, we love to actually. The more we can work together, the better actually. Because any of those problems, it's not something that can be solved by one or two of just a few people actually. I think our goal would be, I assume that most folks on this call would be interested in actually getting the algorithms to work in field, right? So I think that's where we can probably try to work together. There's actually a lot of effort needed.
Yeah, thank you. Hongwei, there's a couple questions in the chat box. Would you like to give a kind of brief answer to those questions?
Yeah, so there's a question. By the way, I noticed that we're already 3 minutes past the original time, but if anyone has any burning questions, and also you have to go very soon, please do feel to just speak up. And then for folks who may be able to stay a little bit longer, we'll be here. We can go over any thoughts. Yeah. So the question is, what applications can be executed on the UE? Also, are some UEs providing sensor data? Testing streaming process. But the answer, let me answer the second question first. Maybe the first one. What applications, right? Essentially, these are all the UEs actually relatively powerful UEs. For some UEs we have cameras attached to them. For example, you can actually stream cameras from the vehicles, from the water towers. There's a little bit caveat there in terms of because some of the cameras may have some like sensitive information, I think. But the short answer is there's actually, we talked about those agriculture application, rural education application, those can be supported by the UEs. Yes, there's actually streaming videos. Actually, we have a 360-degree cameras that will be mounted on vehicles and so on. There will also be sensor data. Yeah. And then there's a question of are there end-to-end experiments possible? The answer is yes. So we have briefly touched on, there's actually the data center servers, there's edge servers close to the base station sites, right? So you can actually have reserve resource end-to-end from UE to base station to edge and cloud computing resources.
Yeah, thank you, everyone. So Hongwei, for the participants still here, and if you have any suggestions or questions, you can unmute yourself. You can ask. Okay.
Yeah, maybe Yung, we can turn off the screen sharing so that we can see people better.
Yeah, sure.
All right. Any other thoughts, questions? Okay, 1, 2, 3. Yeah, so we expect to, again, just as a reminder, if you can help with sharing, providing feedback in the participation survey, we'll reach out to you. I think the near term will be for the beta test. And then we will also start working on the action cluster, some of the action class effort, and so the demo preparation for the public launch event in September. Okay, so there's one more question. Yeah, so eMMC. Does the platform support mobile scenarios for eMMC? I think the short answer would be yes. We have those as we were discussing the vehicles, right? The vehicles, I think they do have cameras. Actually, there are also other equipment that may be connected to the vehicles. So those would be the kind of enhanced mobile broadband kind of applications. Or are you asking about eMTC? If it's about eMTC, I think the answer is also yes. For example, using the I can think about two scenarios. One is actually the open source 5G platform, right? You can actually deploy that. I think there's some eMTC support from the OpenAir interface. Potentially also SRC run too. I'm pretty sure in Open ARA interface there are some support there. And then we do have some IoT equipment it's not like the cellular EMTC type of platform, but there are some other unlicensed band IoT platform that will be deployed for IoT applications.
Okay, if there's no more questions, Hongwei, maybe you can conclude with a few words.
Then I guess we can again thanks everyone for joining us and also for hanging out here until now. And yeah, so look forward to hearing from you and also to work with you in the coming month and beyond. Yeah, so if you have any questions, do feel free to reach out to us. A lot of information will be shared through the website arawireless.org. And we forgot to include this. We do have LinkedIn webpage, a LinkedIn group. If you go to LinkedIn and search ARA Wireless Living Lab, that should be able to take you to our LinkedIn page. We're kind of nurturing that online presence too, as a way of maybe engage folks. All right, thanks everyone.
Yeah, thank you, Hongwei. And then the webinar is being recorded. So at the end, we're going to post it to the ARA webpage. Yeah, thank you.
Yeah, thank you. Bye.